Okay, so this is...
so it has already started?
Yeah.
Oh, okay.
So this is recording now.
Okay.
You can see the button up here.
Oh, okay.
Right? So this is with Ryan's new background subtraction. And I think it works quite well. You know, there's some...
Are you recording the song?
Yeah. Yeah. It's only for me. I'm not going to send it anywhere. But you can see little features here. Right. Oh, okay, anyway. So let's just get on to what I want to ask you about. So if we got the crystal structures panel... now, oh yeah, I need to pull up the this view here, right? This is the image graph, right? This one here. And if I go show interpolation, that's for the tantalum BCC. If I wanted to say the diamond, I just pick diamond here, right?
Ambient pressure.
Ambient pressure diamond, and then show interpolation. We didn't have diamond, okay. So anyway, it was just a test. Yeah, I forgot about that. So tantalum BCC and show interpolation. Okay. So now I want to see what the other features are. So if I go crystal structures panel here. Now, so I know some of these dashed lines here are obviously ambient MGO, so that would be a good one to test. I didn't mean to do that. I meant to look at this one. Why is that doing that? Image. This is because I changed something in the setup to get Marius' thing to work, and then stop working here. Usually, let's see, if I want to change the colour, how do you change the colour normally when you're doing this?
Just the contrast?
Yeah.
You do command 1.
Yeah, so we do command 1 now, it's opening up something completely different.
Oh.
Okay, that's something I just need to make it compatible with Marius. Marius is a new kind of function there. Anyway, it doesn't really matter at the moment. I'll have to try and fix that. So, okay, if I want to see if MGO is working, is a good fit for these lines. So I'd have to put in the lattice parameter. It's a cubic material, right?
Yeah.
And then I'd go to, for example, this website here, and okay, you can tell me. It doesn't matter if it's this one here. I press the MG.
MG.
MG. Okay, and then
You don't need to be connected to.
What happened there? This one. MG. Okay.
And I look for the Pericles.
Oh, Pericles, yeah. That was what we were talking about the other day. Pericles. MGO.
Yeah.
So then that lattice parameter 4.217. Okay, so it was there from last time. So 4.217. And the type, was it F? F for
Phase center cubic.
Okay.
FCC.
FCC, and then I could just say calculate the fraction.
You should first enter the basis.
Oh, the basis, yeah, okay. And the basis, well, the other day we put in MG and O, and is this correct? Or how do
I don't know, you can check on the website.
Okay.
So you go into atomic positions. Yeah.
Oh, that's so nice, okay. And then I can say calculate the fraction. show interpolation. And it looks pretty good, right? But there's obviously some lines that are not captured there. For example, this one here. And some of these, maybe this one here. And so I'm wondering, like, for example, is this line here, is that driven, or is that due to the helium beta? Do you happen to know the helium beta of iron?
Yes.
Alright, what is that?
It's 7.8.
7.8, okay. So we just press 7.8. So what was iron? I can pull up. Okay, I'll find it.
Then so if
recover
you
we just put in FE, right?
yeah, right.
Okay, 7.8. Then
you need to recalculate the. Yeah, could be.
so this line here has not come up.
So you also have iron spectrum.
Oh, we had tantalum pinholes as well, though. I should look for tantalum, right?
Yeah, you should look for all the materials in your scattering environment for that wavelength.
So for tantalum, I could just go here.
Yeah.
Oh, so it looks like it could be a tantalum. This line
Could be
here.
tantalum, yeah. But then, so this is the most intense line for tantalum, right?
Yeah.
And so if you see scattering from these, I would. It doesn't seem right though. Oh no, that's not tantalum. All right, that's right. Okay.
Oh, this one's not tantalum.
No, yeah. So that's why.
So let me just put in FE here again.
Okay.
Yeah, so it's right beside.
Yeah.
That is the driven line, okay, in this particular shot. I was just wondering, is there other?
So if you go back to the helium beta. So you would see this line, that would be this one.
Yeah.
And then this one, is there something below this line? If you remove the interpolation? No, it doesn't seem. But it's less intense, so it would make sense that you don't see this line from the helium beta, because this line is less intense than this one.
That's the helium beta.
We didn't have. Did we have iron? I see a filter edge here.
On some shots we had iron. I'm not sure this is one of them or not.
Okay.
Now this is the first shot we did, so I don't think this has iron. So I mean.
So also the calibration is not great because the.
Well, if I can do the fit again.
No, not now.
Why not?
Well, because you are at the wrong wavelength.
Oh yeah. Okay. So, well, that's a question I have actually. I can do the fit now, right?
Yeah.
So one question I had is, like, all of these, I know these are basically some kind of holding the image plates in terms of rotation and moving them around somehow. Is there some way, I mean, is there some things that you always hold? Or?
No, you shouldn't hold those two here because those define the straight through, the coordinates of and the other one. And then there is no physical reason for having a correlate fit. Might be better.
That moved that a little bit, yeah. That moved it better, okay.
Yeah.
And then I guess I could try it with and without these, right?
Those only if you have. So those two here are the for this panel. So if you didn't put any dots in here, there won't be any constraint for this panel. So you should leave them like this.
I don't think I did put any dots.
Yeah,
There.
so you should leave them fixed, otherwise.
I'll leave them fixed.
Yeah.
Okay.
Or you put some dots on this line and you try to fit them.
Oh, okay. Okay. All right. So it's just a case really of going through all of the. Okay. So if this was B. Okay, so let's go back to this. I can see how there's a lot of different options for the different lines, whether it's tantalum or ambient MgO, and then the helium alpha, helium beta, and you just have to basically go through them all, right?
Yeah, and there are also so the helium alpha is not perfectly monochromatic, so you should test out. And for iron is especially intense. So you have a main peak with satellites around, so you should check also the.
Lyman alpha or.
It's the hydrogen alpha and the K alpha.
Okay.
So you should check all these wavelengths, and you can find the values in Workman's paper.
Okay.
Do you have it?
In Workman's paper, no, I don't. I'll get it.
Okay, I can send it to you.
Okay, if you have it, yeah, you can send it to me. That'd be good. So just as a first cut for if I wanted to get a rough estimate for the pressure for this line here. So we did this the other day. I just change this until I get a fit, and then we could compare with equation of state then to see what the lattice parameter versus pressure would be.
Yeah.
Is that in your paper?
Yes. It's in the form either despacing versus pressure or density versus pressure.
So I would just change this like the 4, for example, recalculate.
It'll be more compressed.
3.7. Maybe get it as compressed as possible. Okay. Okay. Now if I look up that famous Parry Nature Geoscience. So for example, I said 3.68.
Yeah, but that's the lattice spacing.
So how do I?
So you can, if you go to the table, you would see.
What a equivalent despacing.
Yeah, your structure is weird though, because those scroll up, it doesn't find the 111. Why is that? So what you can do, instead of plotting the basis, you can do a simple cubic. So it's an FCC. Try simple cubic, because maybe it's not FCC actually. It's a simple cubic would be P. Maybe it's a simple cubic with a basis, and then you do a refined structure. Try to plot that, but I don't think it's the right one. Yeah. Try to do simple cubic without basis.
How do you do it without basis?
You just click P. You see that you have one atom, and so that's good. Definitely there. Let's see, how did I do it? Because I had noticed that John's program sometimes did something strange. So I have found a trick. So if you do the face center cubic without basis, yeah, that's the right one.
Without basis?
It's because I think so. If you don't enter the right, I'm not sure how the program works for when you refine when you use the refine basis button.
Oh, okay.
There are different ways you can do that, and maybe John is not doing that with the.
Okay, so
The way that I was thinking.
so the 111 peak would be at a despacing of 2.12, right?
Right.
And so
But okay, but what you don't see it. What you see is you have moved the lattice parameter to fit the most intense peak of the B1,
yeah.
which is the 200. So you should check the despacing of the 200 to get the.
200 is the most intense peak?
Yeah.
I know this is in your paper as well. I just want to have a look at it. B1 200. Okay. Okay, so that's the 200 peak, and so we should look at that. So 1.84. So for example, this is so 1.84 would be something like
Wouldn't be a little.
no.
Oh yeah. Oh, you're right.
So let's say. Oh, I should not zoom out as much. So about 1.5 megabar.
Mm-hmm.
Okay, great. Thank you.
So yeah, for plotting the B1 phase, you use, if you don't put the basis, you use just the phase center cubic, and for the B2 you use the primitive, so the P, simple
With
cubic.
the basis?
Without the basis.
Without the basis
Yeah.
as well?
Yeah.